So now, yesterday, correlated subqueries and correlated subquery definition were taken out. Okay. And what we said, the definition of correlated, first outer, later, inner. And this is our syntax to find out and the highest or lowest salaries. Okay, now whenever you want to find out here, highest and lowest for nth position, this is one common syntax to finding of high and low. Okay, now. But the syntax is careful observe. This is your syntax. But when we are working on examples, okay, you will understand that how it was going to be work. Okay, let me come out and see. Take first example. Right now, write a query to find out the first highest salary employee details. The first highest salary employee details. Okay, right. So in this case, what we need to find out here first highest, but already this first highest salary employee details how to fetch, we are already using non-correlated subqueries. But non-correlated subquery, we know how to write to find your first highest salary. And now we will see the correlated subqueries. Okay. So now let me come out and see. First of all, in my database, what I'm going to do, I will go to create one sample table in my database now. For a small table, I'm going to create now. Okay. Now let me come out. One sample table I'm creating. The table name is test. Suppose employee name, varchar 2 of some size, and salary. Okay, right. So later few records I'm inserting into this test table. Some name 85,000. Okay. Now see here the table test now. And this is your table now. Okay. Now total 6 rows we have and 6 employees we have here. So on this table, now we need to fetch a first highest salary by using of your correlated subqueries. Okay. Now let me see. Yesterday I was given syntax to you. Can you read syntax? All of you. Check it out. What is your syntax? Select a star from table name. Test is my table alias name T1. Where n minus 1 is my formula, but how I knows n value. Okay. N value, how I know. Here observe. Here, which highest salary we need to find out, that is called as a n value. That is called as a n value. So here I am finding first highest. It means my n value how much? 1. So that means the solution for n. Okay. So if your first highest salary, so that n is equals to 1, that 1 you need to substitute in your formula n minus 1. Then 1 minus 1 is equals to how much? 0. So this is how it was taking off your n value. Okay. Now you can come out and query where n minus 1 plus how much? 0 is equals to of select. We are using count. Count which keyword? Count of distinct column name. So my column salary from table name test, table alias name T2. Next where table alias name 2, that means T2 dot column name greater than or less than. Okay, greater than or less than. Here I already set you here greater than or less than. Here I'm not giving this point should be right. So where you want to use greater than, where you want to use less than. Okay, so you have to take here use greater than symbol to finding of a highest salary. To finding of highest salary. Use less than symbol to finding of a lowest salary. So finding of lowest salary. Okay, these are the two symbols you need to find out here. Now tell me which highest now? First highest. That means what I want to use? Come on. Greater than. Syntax follow, yeah. Syntax follow. Why are you saying that? Next table alias name 1 T1 dot call. Okay, na? Syntaxes follow it. Syntaxes follow, na? Then you can understand mechanism. Okay, how I'm writing query, you can understand. Without syntaxes, you can't. Okay. So now this is our query statement. This is correlated subquery. Understand na? Now I'm executing now. First observe. Something is missed. What will miss? Salary was there. Okay. Closing bracket. Okay. Now I just close. So now I'm getting here my first highest salary people information. I got it. Okay. Suppose this is first highest. Suppose we need to find out now third highest I wanted. Third highest I wanted means I don't want to change anything here. Where you want to change? N minus 1 I want to change. Third highest means n equals to 3. 3 minus 1 is equals to 2. Just have to put it here. In place of 0, I want to put what now? 2. Now you can see. So I just give it here in place of 0, 2. Okay. 2. Same count, test. What next? Where condition. Okay. See, that means my syntax is common. My syntax, everything will be same. But what I'm changing? N minus 1 formula I'm changing. Now I can execute third highest. Got it? But the same thing if I want to write into non-correlated, how many queries? 4 queries. 3 inner queries, 1 outer queries. So total how many queries we written? 4 queries we written. But here how many queries we written? Only 1 subquery we written. Only 1 subquery we written. 1 inner query, 1 outer query. Okay. Suppose if anybody asks you fifth highest salary. Fifth highest salary to find out by using of non-correlated, then how many queries we need to write? 6. 5 inner queries, 1 outer query. Total 6 queries we need to maintain. But correlated, see, I don't want it this all. I don't want it this all. Fifth highest means 4. Just my n minus 1 formula should be used. Okay, na? Right. And after this is. And to execute, fourth means fifth highest salary, we got it. So fifth highest salary, we got it with only one single subquery statement. Suppose then your interview person is asking 30th highest salary. Then are you writing 31 queries or just putting 29? 29 is enough now? Yes, then query will come to you. Suppose if anyone asks you 150th highest salary, then in place of this 149, query will execute. Suppose you want to find out 2023 highest salary, then 2022. Okay, in place of this, then your output will come. So any nth highest position of salaries, you can fetch it out by using of only one subquery statement. But the same statement, if I want to use into non-correlated mechanism, you have to write a n plus 1 queries. Understand? Na? So n plus 1 queries we need to use. But here we are writing only n minus 1. Okay, this is very, very simple. But how this correlated internally working? So that is important for you. Now take siding. First one, this is. Okay, take this query syntax. The table one also can write if n equals to 1, n minus 1, 1 minus 1 equals to 0. That must be right on, okay? Okay, right. But this, okay, output and query execution internally, how it will be. Okay, now let me come out. All of you remember self-join? Remember self-join, how it was comparing each row to row, how it was comparing, all of you know now? Same as correlated subqueries also. By taking off these two alias names, how I was taken, based on this, here also each and every row will be checking by itself. Okay, now, so let me come out each and every line I will explain to you. Okay, so come back here. now. So now this is your query statement. So where T2 dot salary greater than T1 dot salary. Okay, I just keep it this. And we all of you know this whenever you want to create alias names. When you created alias names, what happened? What happened here? Go to self join. Go all of you self join. Open your self join. Self join definitions, read the points, whatever I was given for self join. Read the points. The blue shirt. Stand up. Read the points. Read. Mm. Mm. Speak loud once again. That point, last point. Once we created alias name, internally system created virtual tables. Why are you forgot it? Some statements are blind statements, remember. So here what happened? How many aliases I created? T1, T2. So that means how many alias tables? Two tables. So now I'm creating two alias tables. This is one table. And I will take one more with some columns. Okay. No. And this is your aliases. Okay. So I will give it here. What is this? T1 and here T2. Okay. And you know this column names here, E name. This is what now? Sal. And here also I'm taking here Sal, some name. Okay, fine. And your table. So come to your table now. So select Sal from test. This is my salary information. I just go to copy this. And we want to paste into this here in salary column. Okay. And the same as second table. Okay, right. So these are two aliases. And the next one is what now here? Your n minus 1 formula. That means 0 how it was came, sir. Here my 0 how it was came. So there is a reason behind here. So what is the reason for that solution? We are finding first highest salary, that is n equals to 1. Substitute that was into n minus 1. Then what it was happened? 1 minus 1 is equals to 0. Okay, so that means your outer query where conditional, okay, where conditional value is 0. So outer query where conditional value is 0. The 0 I just kept here. Okay, na? With this 0, I want to compare with which query? Inner query values. So that means outer query where conditional value is already there here 0. Okay, na? With this 0, inner query, later it was executing what now? Inner query. Inner query, after execution of inner query, whatever the values are come to us, that each and every value of inner query will compare with what? 0. Understand? Na? Each and every value of inner query should comparing with the 0. In this comparison, wherever your condition will be satisfied, then that row will be picked from your table. Understand? Na? So now here it was. Okay. Then comparison. Comparing now outer query aliases and n minus 1 value, how it was came, I explained. Now come to inner query now. Inner query, we written what now? Count of distinct salary we written. Okay, here count function we all of you know. Yes or no? Count function all of you know. Count function all of you know. Count function use is what now? Counting number of values. Distinct keyword purpose is what? In this counting, duplicates are eliminate, don't count. Okay, na? These are all we discussed in early classes. Okay, there is no new topic here. Already in basics we discussed and we came into advanced topics. Okay, na? Right. So now this is what next come out. Inner query. In inner query, this is your condition. This is called your inner query condition here. So T2 dot salary is greater than T1 dot salary. Understand? Na? Now we can check it out. In this aliases, T1 and T2 aliases, which is your, that means T1 is called a outer alias. T2 is called a inner query alias. But in correlated subqueries, your execution starts from inner to outer, outer to inner. Outer to inner. Outer to inner means my comparison should be do from T1 to T2 comparison do it. Okay. So now T1 to T2 comparison you have to, because T1 is called as what now? Outer query, and first outer query executing. That's why your comparison T1 to T2. And now compare here. Which symbol? Greater than symbol. Okay. Now here T1 to T2. So T1. So T1 is first value is how much here? 85. And here I want to take a greater than symbol. I want to take a greater than symbol. For your confusion, what I am doing here, this table names are I'm changing now. Better to without any confusion. Okay, na? So now what I'm putting here, 1. This is T1 and this is a T2. Okay, na? Right. Sorry, again T1 na. This is what now? T2 and this is T1. T2 and this will be make it a T1. As per my condition I want to take. Okay, na? Right. Now comparison start. T1 to T2 comparison. Okay, na? Now let me see how to compare means each and every row value should be compared now. First row I'm comparing. 85,000 I'm comparing now, which each and every row. So each and every row I'm comparing now. So 85,000. 85,000 I'm comparing now. Okay, na? 85,000 compare with the each and every value. Each and every value. Okay. In this comparison, now tell me, 85,000 above. Greater than means what now? Above. Above 85,000 above. How many values are there in my T2 alias table? 85 above. How many values are there in T2 alias table? No values. Is there any big value? No. 85 is only biggest value. 85 above biggest value, is there anyone? No. No means my count of distinct salary. What it was written? What is your counter? No means count is what? 0. So that is what I'm writing here. So 85,000 above, there is a no value in my T2 alias table. Okay, na? So that's why my count of distinct salary, this function will be written how much here? 0 will return by count function. And this 0, whatever it was written, this is what? Inner query value. Inner query condition checking, and whatever the value returns, that value now I'm comparing with the outer query 0. Now tell me, 0 is equals to 0. Condition true or false? Condition true. At which value? 85,000. So that row will be pick from your table and keep it that. Same as remaining all. Now next record. 45, I want to check. 45,000 above. How many values are there in my T2 alias table? 45 above. One is 85. One more 85. One more 59. But 3 values are which is bigger than 45. But in 3 values, in my count function, what I am using? Distinct. Distinct means the duplicate is counting or not counting? Not counting. So where is duplicate? This is, I am not counting. After eliminating of duplicate values, final count is how much? 2. And that 2 I keep here. Okay, na? That 2 I'm keeping here. Now this 2 compare with your row. 0 is equals to 2. Condition false. Next one. 22,000. 22,000 above. How many values are there? One is 85, 1, 45, 1, 85, 1 more, 59, 34. Out of 5, 1 duplicate, eliminate. Just eliminate. Remaining 4. The remaining 4. That is called a count. Count of your 4 is count. This 4 count you need to compare with your 0. 0 is equals to 4. Condition true or false? False. Keep it like. The next one. The next one is what now here? 85. 85 again compare with all the values now. Tell me, is there any value? No. No means it was showing what? 0 again. So 0 again. This 0 compare with your outer query value. What is outer query? 0 is equals to 0. Condition what now? True. At which value? 85,000. Okay. Next. Come to next one. 59,000 I have to check. 59,000 above. How many values are there in T2 alias table? Okay, na? 59 above 1, and this is 2, but second not counting. Total only 1. The 1 count I will kept here. That 1 count is just count with your or compare with your 0. 0 is equals to 1. Condition what? False. Next one. Next one is what now? 34. 34,000 above. How many values are there? So above 1, 2, 3, 4. But you have to, okay, don't count 1. Total how many here? 3. Okay, 3. The 3 compare now. 0 is equals to 3. Now condition true or false? False. So false. So now check. Your all rows are comparing any row is missing. No, each and every row compare. After comparison, where is your, okay, here it will be satisfied. Here it will be satisfied. So 85,000 is called as first highest salary. Got it? How this first highest salary it was came out? Internally correlated subquery is executing like this, checking each and every value, that inner query of each value comparing with the outer query of where conditional value. So with 0, your inner query values are total 1, 2, 3, 4, 5, 6. 6 are comparing. In this comparison, wherever condition true, the true conditional data or value will be picking from your table. Answer is got it now. Who is the first highest salary? 85,000. How many people like this? 2 people in my table. The 2 people will come to us. Understand? This is what we call. And now we can see. This is correlated mechanism. Okay, na? But the sir, here same thing. Okay. Instead of correlated, even though I can write a non-correlated also, where salary is equals to, what is non-correlated? Select a max of salary from EMP. Same output. Sorry, this is that table, EMP table. My table I want to change. Test. From test. Okay, right. Same output is K. But in this 2, I said non-correlated subqueries performance-wise is very high compared to no correlated. So now how it was served. So now we can see. In my table, how many values are there? 6. Okay, in my table I'm saying what? Table. What is the table test? In my table, how many rows? 6 rows. It means what it was happen. Non-correlated subquery. First, which query execute? Inner query. Inner query executed. Inner query, what it will do? It will be pick highest salary. What is highest salary in this? 85,000. So, after checking each and every row in the table, which is the highest value, that highest value will be pick. That means here how many rows are comparing or how many rows are checking? 6 rows. Okay, 6 rows. After 3,000 will come to you. Sorry, 85,000. 85,000 will come to you. Inner query result. This 85,000 again I'm going to compare with the outer query. What is outer query? Select star from table name where salary is equals to 85,000. And again this condition checking with how many values? 6 values. So inner query, see, inner query comparison returning purpose 6 times comparing for max value returning. After retrieving max value, again comparing with your outer query, how much here? 6 times. So 6 plus 6, how much here? 12 times it will be. So that means your non-correlated subquery compared how many times? 12 times compared. Inner query 6 times, and whatever the result will return for us, based on that result, outer query 6 times. So 6 plus 6, 12 times it will be performed, or it will be compared. Okay, now? Now, keep it, this is non-correlated subquery. Correlated subquery, same question, same output. How many times you can say? First, inner query executed. Inner query, what I'm saying here, each row or each value is comparing with all values of another alias. Yes or no? That means how many values are there in my table? 6 values. So 6 into 6, so total 36 times. How many comparison? 36 times comparing. 36 time comparison. Okay. Whatever it was come values 1, 0, 2, 4, 0, 1, 3. These are what now? Inner query values. So after 36 into 6, 36 times if you compare, inner query values are came to you. Again, these inner query values are comparing with the 0. How many times? Again, 6 times. Okay, na? So 36 plus 6 times. Total 42 seconds. Same output. Finding of first highest salary employee details. If I need to find out that employee, non-correlated subquery will take 12 seconds of time to produce your result. But correlated subquery take 42 seconds of time to produce same result. Now tell me, which is fast? Non-correlated. Which performance is good? That's why in my starting class I said 99.99% of real-time people, their first priority to whom? Non-correlated. And correlated when they want to use, I said, when our requirements are fulfilled, but we are writing very complex query, there you can use a correlated. That is one case. Second one is what now? Your requirement is not fulfilled. By using non-correlated subquery, there you can use a correlated. Other than these two situations, correlated don't use it, because it was a very high time period or time consuming process. This is okay now. So this is what now the differences of correlated and non-correlated. Okay. Total 6 into 6 comparison. After that, inner query, each and every value of inner query again comparing with the outer query. So here 6 time. Here 6 time comparisons. There 36 time comparison. Total 42. Okay. So that's why correlated performance will be very low compared to non-correlated. Now clear all of you now? If any interview person is asking why we want to give priority to non-correlated and why non-correlated performance will be more than correlated. If anybody ask you, then this small example explain to them. Okay, na? Easily they can understand that. So now clear all of you? This is what it was going to be happen. Now same question I'm asking. So this is my first question. Write down second question. Write a query to find out. Write a query to find out the fifth highest or else fourth highest, the fourth highest salary employee details. Fourth highest means my n-1 value how much? So here n is equals to 4. n-1, that's called a 4 minus 1 is equals to 3. And the 3 I just substitute here, then your output will come to you. Right down. Complete. Hmm. So now you can see here I was given 3. Okay. And this entire the query, if you see this to execute here, the fourth highest I'm asking. Which one is fourth highest? This is first, second, third, and fourth highest. How much? 34. Now let me go and check. Got it? Now here n minus 1 is equals to how much, guys? Here n minus 1? 3. Now compare here. Wherever your 3 is satisfied, observe. So my outer query 3. 3 is equals to inner query. First inner query count is how much? 0. 3 is equals to 0. Condition true or false? False. Next count. 3 is equals to 2. Condition true or false? False. Next count. 3 is equals to 4. Condition false. Next count. 3 is equals to 0. Condition false. Next count. 3 is equals to 1. Condition false. Next count. 3 is equals to 3. 3 equals to 3. Satisfied? Yes. At which value? 34,000. So 34,000, which highest salary? Fourth highest salary. Are you clear now? So like this, each position you will be count with the count of inner query values you need to compare here. Okay, now? Right. So now write down. So now this is called a highest. Now can you find out any position now? Yes or no? If any position means, if I'm asking 50th position, then just 49 keep it. That's it. Okay, 72 position, 71, 104, 103. Okay, 270, 269, 1024, 1023. Simple. Only one subquery. Okay, but you can finding any nth highest salary. 1,000, 2,000, lakhs of highest salaries also you can find out. Understand now? So this is what we called your correlated highest. But the same thing I said here, nth highest, how you find out? I want to find out nth lowest salaries also. Okay, but in lowest salaries also same as usual. Okay, but in place of your greater than symbol, what I want to use? Less than. Now write one example on this. Write a query to find out the first lowest salary employee details. So now tell me, what is your solution now? N value how much? N value how much here? N value 1. Very good. 1 minus 1. N minus 1 value how much? 0. N minus value 0. 0. But where I want to change? Inner query condition. Inner query condition, what I was taken actually? Greater than. In place of greater than, what I want to put? Less than. That's it. Then you can find out your lowest salaries also. So now just come back and see. What is my first lowest salary? 22,000. Okay, na? So here also same thing, comparison. Now this time comparison is what? Less than symbol, right down below. Okay, right. So now same as, can you find out any nth lowest? Yes or no? Yes. These are nth highest. By using of correlated subqueries, even though we can find out the next level, uh, syntax to display, syntax to display top n highest or lowest salaries right now. So your syntax difference is what now? In place of n minus 1, put it n greater than. That's it. Remaining all are same right now. Okay, right. So by using of this syntax, okay, we can find out the top n people data. Okay, write on example. Write a query to display top three highest salaries, top three highest salaries, employee details from EMP table. Okay, right. So top three highest, let me come out and see. Suppose in my table, okay, don't write, just observe. If you take in this table, top three highest means n equals to how much here? 3, direct 3. So select a star from test T1 where 3 is greater than of select, okay, same as usual, count distinct of sal, okay, from test T2. The condition is what now? Where T2 dot salary which is greater than T1 dot salary. Okay, now I'm executing now. The top three highest salaries here, see 85, 59, 45. Okay, now these are top three highest people. Now, but this condition how to checking means the same as usual. Same as usual, you can come back. These are already we have a countings. Okay, now already we have a countings. Now my outer core is what now? 3 is a 3 greater than here. Okay. Now inner query values compare now. First value is how much? 0. Now see 3 is greater than 0. Condition true or false? False. Condition true. Condition true. Condition true means which value returns? Which value returns? 85,000. Next compare. 3 is greater than count is 2. Condition true. At which value? 45. Next. 3 is greater than how much here? 4. Condition false. Next, 3 is greater than 0. Condition true. How much value? 85. Next, 3 is greater than 1. Condition true. Which value? 59. 3 is greater than 3. False. So top highest how much here? 85, 59, 45. Understand now? So now this is. So how it was came. And now you can come out here. Let me come out and see. This is select a star from EMP. Suppose this is your big table. If you want to do on big table. On big table, first highest how much? Second highest, third highest, 2975. Now see, same mechanism you can apply on big data tables. Okay, how to write? Select a star from EMP E1 where 3 is greater than of. Select a count of distinct sal from EMP E2 where E2 dot salary which is greater than E1 dot salary. Okay, na? Now you can see, got it? First highest salary, second highest salary, third highest salary. Okay, right down below. Okay, right. Same thing. Suppose if I'm asking to you, I wanted top three lowest salaries I wanted. So here my syntax query, everything will be same. But so many people, what they will do, they will be thinking like that. Here they want to change a less than. Who are writing like this? It's a blunder mistake. Okay, na? So because n greater than is my fixed formula. N minus 1, n greater than, these are the formulas. I cannot change these formulas. So that is the reason lowest salary, highest salary, you have to use these symbols. In which class, in which query? Inner query. Okay, na? So that is the reason inner query level, these two was given. So now what happened here? Don't change like here 3 less than here. Okay, put it here, changes where now? In place of this, put it a less than. Okay, na? Now we can see on my EMP table, the three, okay, top 3 least salaries, how much here I can see. I want to execute. Now, who is the top 3 least people? 800, 950, 1100. These are the top 3 lowest salaries employees. Right on below. And below, along with that, note point right on. To find out n the highest or lowest salary, n the highest or lowest salary, your formula will be n minus 1 formula use. Second one, to display top n highest or lowest salaries, to display top n highest and lowest salaries, then your formula will be n greater than. Okay, na? So these two formulas fix. Okay. Okay. So these are one type of operations with the correlated subqueries. And now next one right on here, exist operator. Exist operator. Okay, right. So exist operator, this is one of the special operator guys here, but this special operators are specially designed for correlated subqueries only. And this operator you cannot use into non-correlated subqueries. You never use it. And this is specially designed for people to use under correlateds. Okay, now? And now, with this operator, what I can do means that your required row, for example, this is my table. I have some rows. So 30, 40, okay. So some rows are there here. So now what I want to do, my required row, suppose my required row is 10. If I wanted 10th row, this 10th row is existing in my table or not. I want to check. So existing operator, what it will do, your required value is existing in your table or not. That will be check. If your required value is existing in your table, then it returns what now? True. The value will be pick. Okay, now next I'm asking. My next value is what now? 50. The 50 value is existing in my table? No. No means this 50 value written or not written? Not written. Okay. So that means existing operator, what it will do, it's just going to be check our required row is there or not there. If it is there in the table, returns true. If it is not there in the table, returns false. This is the purpose of exist operator. Right down below. Exist operator, right down. It is a special operator. It is a special operator which is used in correlated subqueries only. In correlated subquery only. Okay. Now, this operator is used. This operator is used to check a row is existing. A row is existing in a table or not. Okay, na? Right. Suppose if a row is exist, okay, exists in a table, okay, then it returns true. Then it returns true. If a row is not exist, if a row is not exist in a table, then it returns false. Then what is the syntax of this? The syntax is where exist of you write your inner query. Okay, now. So let me see examples on this. write a query to display department details in which department the employees, or in which department employees are working. In which department employees are working. Okay, right. Question understand now? What I want to display here, department details, not employee details. I want to display department details. Which department details I want to display? In which department employees are working. Okay, na? Now let me come out and see. First of all, observe. Suppose here I have a one table. Okay, the working table EMP. EMP table, I have total 14 employees are there. But this is completely employee related data only we have in this. There is no department's data. It's only employees data was there. But I want to display what now? Employees data now or department's data now? Department's data. But department's data here it is not there. Department's data having into another table, that is DEPT. So in this table we have a departments. EMP table have a employees. So my question is what now? Who are there here? These 14 employees who are there in my table. These 14 employees are working under which departments that I want to know. Okay, now these 14 employees are working under which departments? Accounts, research, sales, and operation. Suppose, so 14 out of 14, some people are working on accounts, then accounts will take. Some people working on research, then research will take. Okay, that means 7 people working in accounts, 7 people working in research. It means this total 14 employees are working under which departments? Accounting, research only. But remaining 2 departments also there in my company. But these 14 employees are working there? No. That means what is my answer? My answer is accounts, research. Yes or no? So that is what I need to find out. Now we can check it out. But sir, to finding of that accounts or that department details, what is the problem here? My required information, the which data I need to compare here, the comparison of data is having in 2 different tables. Yes or no? Employees data in one table, departments data in one table. Now think, our required data when it was having in 2 different tables, how I can compare? Yes, by using joins. I have to go for join. So here I want to implement a join technique. But when I want to use join techniques on these 2 tables, what should be required? Common column. The common column should be required. So first you have to, I already said to you, when you want to join 2 or more than 2 tables, first your idea is what now? In these 2 tables, common column is there or not there? That is my first thought when I'm doing joins. Okay, na? So now check it out. Is there any common column? Yes. Department number. This is common column. So when we have a common column is, can I write now? Yes, I'm going to join this. Okay. So now what I want to do, careful observe. First in this 2 table, based on common column, which department numbers are common? Common means matching. First the departments I have to pick now. Now see, in department number of EMP table, department number of DEPT table, what is the common? 20. 20 is there? Yes, matching. 10. 10 is there? Yes, matching. 30. 30 is there? Yes, matching. 40? Not there. So that means matchings are what? 10, 20, 30. Now I'm going to writing. Careful observe. Select star from DEPT D. Because I want to display department details. That's why I'm using DEPT D. Okay. Where? Which operator? Exist. Where exist? Inner query. Inner query, what should we take? Department number. So select department number from which table? EMPE and condition. What is the condition? Where E dot department number is equals to D dot department number. Okay, na? In this correlated subquery, first which query executed? Outer query. Outer query executed. Outer query if executed, this is your output, na? Yes or no? Select a star from DEPT. That means this is my entire table will be written for me. So tables came. Then after, what is the condition? Exist. Exist. Okay, exist condition. Exist of which query? Inner query. Inner query as per this condition, which departments are matching? Which departments matching? 10, 20, 30. So this is inner query result. Inner query result. This is outer query result. Now check it out. Now inner query value. Now check it out. 10 is existing in this table or not? Existing. So it means it returns what now? True. 20 was existing in this table. Yes, existing. So it is also returns true. 30 is existing in this table. Yes, existing. So that means it is also returns true. Okay. So as per my inner query result, that inner query values are existing in your tables or not, we are checking on by the help of which operator? Exist operator. If it is existing, return true. Not existing, false. So now unfortunately my all values are existing in my table. So that means finally, what is my answer for this query? Accounting, research and sales. But is there any employees working under operations? Working? No. Operation department number how much? 40. In EMP table department number, is there any 40 was there? No. That means my 14 employees are working under 10th department, 20 department, 30 only. But there is no employee working under 40. Like this also you can compare your tables. Okay, na? So now write down below. Okay. Same as this is positive operator. And next negative operator we can write. So display department details in which department employees are not working. Not working means what I want to use here, not exist. Can you remember in, not in, between, not between, is null, is not null, like, not like. Same, exist, not exist, positive and negative. Now we can see in this example, I'm using not existing, not existing, I'm asking. So in which table employees are not existing? 40th table, there is no employees are working. Okay, now right down below. Okay, right. So these are what we called correlated subqueries, how it was working. Okay, now and one more subquery was there, non-correlated, correlated. Okay, out of these two, one more we have in the latest versions. Okay, now and that was called as what now? Scalar subquery. Right on. This is one more new subquery was introducing in your database now. That is what we called a scalar. Okay, and this scalar subquery, first I will give a definition. Okay, now some simple understand definition, don't write, observe. Scalar subquery, when we called and how it can be defined means, can you tell me guys here, this is select query, we all of you know, yes or no? Select star from so and so table. Okay, a star means what? All columns. So that means in place of star, can I put like this? Column name 1, comma, column name 2, comma, and so on. Can I? Yes, na? This is also select command, na? There is no doubt. Okay. So either you can use star, instead of star, you can put it a column names. Okay. Now come to what I'm asking, scalar subquery. A scalar is nothing but a single column in your table. Every single column in a table is called as a scalar. So now what I want to do, scalar is nothing but a single column. So in the position of column, what I need to write? Subquery. Understand my point now? So now how I'm writing? In the position of column, I am writing subquery 1. In the position of column, I am writing subquery number 2. In the position of column, I am writing subquery number 3. So, like this, in each position of column, you or when we will be write a subquery statement, then it is called as a scalar subquery. Clear now, all of you? This is the latest one, remember. So, in every column position, in place of column name, I'm giving subquery statement. Okay, now? So that means providing subqueries in which clause? Select clause. Okay, providing your subqueries in select clause is called as a scalar subquery. Otherwise, another definition. Providing subquery in place of column names in select statement. Column names in select statement is also called as what now? Scalar subquery. Okay, right down below definition. Providing subqueries in select clause is called as scalar subquery. Otherwise, providing subquery or subqueries in place of column names in select statement is also called as scalar subquery. Okay, now we are observing one more point here important. So, okay, sir, suppose are you writing one scalar subquery statement like this? Listen, don't write, listen. Are you writing scalar subquery like this? Okay, now? So now what it was happen in this is called a outer query. This is called a outer query. These are called as a inner queries. Okay, na? Inner queries. Now you can see. So first inner query this is. Second inner query. Third inner query here. So scalar subquery also, in which way of mechanism it will be follow means it followed non-correlated mechanism. Non-correlated mechanism will be follow this. Non-correlated first which query execute? Inner query. So that's why here also every inner query first executed. And after executing of inner query, it will return some result, na? Yes or no? Suppose this inner query execute, it was written some result. It returned some result. It returns some result. So whatever the scalar subquery will return your values or output or result, those result will be act as what now? Columns. So that means every scalar subquery result will show as a column. Now see, first subquery result and it was showing as a column data. Second result, one more column. Third result, one more column. So each and every subquery or each and every scalar subquery result will acting as one of the column. How we said inline view, the result of inner query will act as a table for outer query. Same as here also, the result of a scalar subquery will act as a column for outer queries. Outer query means which one? This one. Okay, na? That point also add. What is the next point? The result of scalar, subquery will act as a column for outer query. Column for outer query. And now below write down syntax. Okay, now right. So this is one of the latest subquery in your database now. Okay, now. So now this is definition and the working nature as well as the syntax and practical examples. Okay, now that we will see in tomorrow's session. And tomorrow your subqueries concept will be completed, and I will start it one more new topic. Okay, now right. By this end of this month, your SQL is completed. Okay. So end of this month, your SQL will be finished. And May 1st, maybe we will start PLSQL, second part. And second part will take almost 15 to 20 sessions. So that means your batch complete Oracle is completed mid of the May. Okay, mid of the May, it will be finished. Okay, na? Right, guys. So I stop it here. So exactly 1 month is there. Huh? I think your batch have very fastly completed. Huh?